Welcome back to Smart Architectural Programming. In today's video, part of our companion series to our Introduction to Java book, we're diving into one of the most asked about topics in object-oriented programming, method overloading versus method overriding in Java. Generally speaking, the point that you need to understand with these two topics that we've already covered these two in our previous video. So if you don't understand them individually, you can go look at our detailed videos previously. But in this video, we'll be going over what these methods are as well, but in a brief note, as well as comparing them, trying to contrast the exact difference, because beginners have usually found that they confuse these two topics, which is not conducive to your abilities as a programmer to do object-oriented programming. So understanding these terms and what they stand for is essential, and that's what we'll be focusing on in this video. So number one, what is method overloading? Basically, it occurs within the same class where multiple methods have the same name but differ in parameter types and number of parameters or both. What do I mean by that? So let's put it this way. If we have a function, a class, right? Let's have a class. It could be anything. That's a blueprint for a method. So within the class, we'll have one or two functions. Maybe we have two functions with the same name, f1 and fnf, right? Two functions with the same name, or methods with the same name, right? We call methods functions in other languages. But they might have different parameters. By different, these two functions, assume them they're add functions, right? So one add function might have two parameters, the other add function might have three parameters, right? They're different. Or one add function might have integer, two parameters which are integers, and the other add function might have two parameters which are floating point numbers, right? At the same time, they could have different number of parameters as well as different types at the same time. So that is the crux that you need to understand with method overloading. They're the same similarly named functions with different parameters, right? That's the foundation on which you can further understand method overloading. This is just the first part. The other part, that we might cover in next, but that is something you need to understand at this point. And let's bring focus on these key points here, right, that you see here. We need to understand methods have same method name, right? That's important. Then they have a different parameter list, which is either type or number or both. We understand that. It happens in the same class. We covered that. And it is resolved at compile time. We haven't covered that, but you get the gist of it. Just keep that in mind, but the other three are the very important aspects to this. So let's look at a piece of code here. You see a class with three print statements here. All these print methods live in the same class, but Java knows which one to call based on the arguments you pass to it, right? That's compile time polymorphism or static building, right? So that's what we mean. The fourth point was compile time running, right? Which it means it's static binding and it's compile time polymorphism. What that means is if I call a print statement, let's say I call a print statement, right, and give it I don't give it any numbers, I give it a string s, right, to print. Now, which particular function from this would be selected? Java would go at our function number 1 here, it would go to our function number 2 here, and it would go to our function number 3 here in the same class, right? Keep in mind this is a class-based function, so I'll write assume p is printer. So printer.print s. It goes here and sees this is a string in this function that we're calling. And based on that parameter, it understands or deduces this is not going to be the function it's going to use. This is not going to be the function it's going to use. It's going to use the first function here because it has a string text and one string text as its only parameter. But if I had a number, let's say 5 in the print function, it would have used number 2. Say I had an integer and a string both, let's say s and 5, it would have gone to method number 3. This is basically the second half of method overloading that you need to understand, right? With that, let's move on to the next part of this video, which is method overriding, what it is. So method overriding happens between a parent and a child class. The child class provides a specific implementation for a method that is already defined in its superclass, right? What does that mean? Presume I have a function called, oh, rather I think we'll cover it in more detail in the code example on the next slide. Let's cover on the main points that I discussed right now in the definition. It has the same method name and signature, right? Same parameter, same method name, everything is the same. There's the parent-child relationship between the classes that have method overriding. One is the superclass, which is the parent class. The other is not a superclass. It's a child class, right? There's a relationship there when method overriding happens. Then we have let me actually use red here, considering this blue is being covered up. So we covered this and we covered this right now, right? So then is the override. Focus on this. So this is basically used when we are trying to override a class in the child class when using method override. So this is something that we'll cover in the code that you'll see next. And it's resolved at runtime, which is dynamic binding, which we might cover in the next slide as well. So let's look at the code base here. So again, this is what we have. This is the parent class. This is the parent class, and this is the child class, right? First, let's just define that right out of the blue. So when we have these two classes here, so we defined the sound function for an animal in the animal superclass or the parent class here, and we have defined the same method sound in the child class, right? But you'll notice we use this @override keyword here right before we define the sound class again in the child class. So what happens is, if you look at the animal class, we print out animal make a sound. It's generic, it's because animals can make any sound. But we're defining the dog class, child class from the animal superclass. You notice we're overriding the sound function to make it say dog barks, which makes sense, right? And the point over here is that in overriding, we try to make sure that the subclass method from a general class is overridden to make it more specific to the function or the subclass itself. So that is the reason for it. And now I think you can understand the difference between the overloading and overriding. Overloading is the same method name with different parameters, and it is chosen based on what parameter is inserted with the same method name by Java at runtime to decide which one to use, right? In overriding, we specifically don't need Java to do any decision making. Rather, we explicitly are telling Java to override a function and use that function for that subclass or child class for that matter. So let's understand how we can contrast overloading and overriding. So let's look at feature number 1 here, right? Class relationship. So class relationship in overloading is the same class because we have both methods in the same class, right? And class relationship in overriding is parent and child classes. We've covered that, right? I'm trying to go over these differences here so we can basically put it in more clear contrast after covering the concepts, so you can try to internalize and make this concept more intuitive. Number 2, we have method signature, right? So it is basically in overloading, the method signature must be different, and in overriding, the method signature must be exactly the same, which is the name of the method. Similarly, if you're not sure what signature means, it means the name. Then we have number 3 here, which is return type, right? So return types can differ in overloading because we have different parameters. The logic is basically can be anything. In the add function, we can add by simply returning it directly, or we can add it using add it first and then do the return function. The logic in a overloaded methods is basically the same. Basically different. Only the names are same, parameters are different, but the logic inside can be completely different, right? And so the return type is also different. So that's what point I was coming across. So when we talk overriding, the methods must be the same, but return type must be the same because the logic is the same. It's just there's a variance of that logic that we're trying to override, right? And that's basically how it's used. The logic could be different as well, but that's basically logically how we think about overriding when we're coding. We talk about number 4, which is access modifier. Access modifiers basically can be anything in overloading, and basically can be anything in overloading, and in overriding it can't reduce visibility. Number 5 is binding time, which is basically compile time in overloading and runtime in overriding. We've covered this with when we were going through these two concepts in our video earlier. And in use case, which is number 6, in overloading the use case is code flexibility, and in overriding it's polymorphic behavior that we're going for. So let's have a quick quiz here at this point. And test your knowledge of what we've covered already. Try to answer these 3 questions in the comments below. Which concept supports polymorphism, overloading, or overriding? Problem number 2. Can 2 overloaded methods have the same type, same number of parameters? And problem number 3. Is @override mandatory in overloading? Let's spend some time and answer these questions below in the comments below, and pause the video while you're doing so. At this point, I'm presuming you have written your answer in the comments below, and I'll just give you the answers for all 3 problems here. And hopefully you've already solved them and then you're listening to these problems. So the answer to number 1 is overriding. Number 2 is yes if the types differ. And number 3 is no, but it's highly recommended to use this when you're overriding. So with that, I think we're going to wrap this video up. We've covered the method overloading and understood that it helps you offer different ways to perform the same action, while method overriding lets child classes redefined inherited behavior. Both are powerful tools in your Java toolkit. So if this helped you clarify the difference, drop a like and subscribe to Smart Architectural Programming for more insights into Introduction to Java for beginners, and check the description for sample code and exercises if you have some time. With that, we're going to wrap up this video and see you in the next.